So I think I have already covered safety stock already, but I'm going to cover it again because week 6's problem discusses safety stock. So safety stock is stock deliberately held with the intention of meeting unpredictable demand or protecting against unreliable supply. So in general, safety stock is used to absorb variability in either our demand or in our supply. So generally, we place our safety stock near the areas of highest, where we can address the most variation in the demand or supply. And when we set safety stock, there's a nice equation that they use in 42, which is very helpful. But we have very much 3 factors that we consider. We consider the demand rate, okay, how much demand per period. Response is basically how quickly we are able to replace the stock. This deals with our lead time. So, and the replenishment lead time, how long, and replenishment lead time has 3 factors inside. Now, I tend to view these in addition to lead time. So basically, this is pretty much the whole lead time right here. So the time a unit is consumed until it is replaced in the system. That's lead time. For the order, the production lead time is time the order completed to the time the order is produced, and transportation lead time, how much time it takes to ship the product. So in general, when I look at lead time reduction, these are kind of like 3 factors that I look at. I find it easier to understand the lead time when I break down the lead time into like these 3 elements. And I guess you could break it down into more elements, but this is a good place to start when trying to look at lead time. So moving from a decentralized to centralized distribution reduces safety stock because of risk pooling. Once again, my experience, this isn't always true because there's, you always find outliers. A centralized distribution system has higher variation in general because the goal of a pull system is to reduce variation within it. Centralized distribution encourages large inventories because it uses warehousing and everything else. So they're more willing to accept variation in their supply chain. So in one, you trade decreased inventory due to risk pooling, whereas in a pull system, you reduce your variation to reduce your inventories. You're going to read where it says that centralized distributions have reduced need for safety stock. And that's generally true if you look at the math, but in real life, because of the goals of each of the systems, if all things being equal, that is true. Okay. But if you have a decentralized push distribution, this is true. But if you have a decentralized pull distribution, then that's not always correct. Because as I said, the goals within that system are different. The goals within a decentralized pull system encourages less variation because we don't deal with demand forecasting, we deal with actual demand. Okay, does that make sense? Okay, I'm assuming it does. That or you fell asleep. So next, I think. So factors influencing safety stock placement. Just 4 general factors. Customer tolerance. I think I discussed safety stock when I dealt with the demand, the lead time versus demand charts last time. So basically, customer tolerance. How much time the customer is willing to wait. And as I said before, sometimes you get the customer to wait longer. Ideally, that's a good idea. The variable rate of demand. The potential for swings and unexpected. The potential for unexpected swings in demand. Very simple. the variable rate of supply and inventory flexibility. The first two, variable rate of demand, variable rate of supply, deals with the variation in your demand and supply, as you mentioned earlier. And the flexibility is how you place the places in your supply chain where you can leverage things to be more effective. Okay. Now, I think that's it for week 6. So it's just really quick. Now, I'm just going to real quick over week 6 problem. And basically, it's going to give you a problem where you compare the amount of safety stock in 2 systems. You have one system where the lead time, first thing you have a factory, you have a cross dock, and you have a retail outlet. Oh, you have 2 retail outlets, sorry. So it says, compare the amount of safety stock in 2 systems where lead time from a cross dock to retail outlet equals 0, and where the lead time from the factory to the cross dock is 0. And it's going to say, compare the safety stock in both systems. So when we deal with this, what I always recommend for students to do is just draw this out. So if you draw it out, it's going to look like this. Okay. You have a manufacturing facility, cross-dock facility, and 2 retail outlets. In this example, we just, you can view this as a normal warehouse or whatever. The difference obviously is in a cross-dock, there's no shipment time, lead time. Okay, there's no transportation lead time because cross-dock, the materials immediately are shipped out of a cross-dock. That's the only difference. But for this example, usually I say, look, just we can view this as, the same as a warehouse for ease of simplification. So in the first example, it says, so basically total lead time is L1 plus L2. So if it takes us 3 weeks to go from manufacturing facility to cross dock, and 3 weeks to go from cross dock to the retail outlet, then it's a total of 6. So they're saying, think about if the time to go from the cross dock to the retail outlet is 0. Okay, basically you've positioned the cross docks basically right next to your retail outlets. Okay. So if this is the case, then L2 will be 0. So in this case, I just use number 6. So obviously all the lead time will be located at L1. And if you look at where the lead time from the manufacturing facility to the cross dock is 0, then all of your lead time is at your retail outlets. So where would you put your safety stock? I'm not going to answer the question for you, but just remember that safety stock goes where the most variation is felt. So which of these locations would have more variation? The one where there's no demand, I'm sorry, where there's no lead time, or where there is all the lead time exists. Now, one thing that they don't cover in the problem is the variation in demand. If you want to address the variation in demand in your question, in your answer, that's great. I'd love to see it. But if you want, you can only just deal with the variables that are given to you. Okay. So remember from when I was talking earlier, the safety stock is placed to absorb variation, which basically to address our customer service level. So which of these locations, based upon the lead time location, would have the highest effect on the customer service level? So are there any questions overall? Okay, I'm gonna assume not. So if there's any questions, please feel free to post them in the class, and I will address them. So quick close. I'm going to be going over the week 5, the group term project progress reports, probably soon after the first of the year. I'm going to give all the groups the ability to post and updates. I haven't gotten them from all the groups yet. So if you haven't seen anything from me regarding to your groups term paper progress, then have no fear. You should see something soon after January 2nd. And all right, I think that's it. So unless there's anything else, I am going to log off.